All right, so 59 says Jed is standing 10 meters from a maple tree. That's 14 meters from a willow tree, as shown as the picture below, in which the measure of an angle is given. It says which of the following equations, when solved for x, gives the distance x meters between Jed and the willow tree. All right, so we're trying to figure out this section. And then it tells us a note. Anytime they have a note, it means heads up, a formula is about to come. So it says for a triangle with side length A, B, and C that are opposite angles, angle A, angle B, angle C, respectively. So that means that A goes with angle A, B goes with angle B, C goes with angle C. So respectively like means in order of how they just named them. All right, so A and A, B and B, C and C. And then it tells us the formula right here. All right, this is called the law of cosines. We haven't learned this yet, but we will eventually learn it. So c squared equals a squared plus b squared minus 2ab cosine angle c. So what's important to note here is that these little angles are sides. Right, so each of these is a side, A is a side, B is a side, and then the angle C, right, angle C is an angle, right? So if I have these two things have to go together, right? So whatever C is has to be the side that's across from the angle that we have. So in this case, we only have angle 34. So I know that 34 is going to go here, so it's going to be cosine 34 degrees, which means that C has to be the one that's right across from it, right? So C squared has to be 10 squared. The other ones, A and B, can be the other two sides. It doesn't matter what order they go in. So I could have x squared here or 14 squared here, or I could have 14 squared here or x squared here, right? It just means that whatever I have, I need to check to make sure that I have 10 out here and 36 here, or 34 here. So see all of them have 34. And then I see that some of them have 10 over here. I want to choose the ones that have 10, so I'm not choosing C, D, or E. And then they have this same section here, and then it says 2x14 cosine 34, or 210 and 14. So we notice that, let's say, we'll just use this first section here. So let's say we had our x was A and our B was 14. Then in this case, our x would be A and our B would be 14. Right, so 2x times 14. We can see that that one is the first one. We don't want to have another 10 in there, right? The 10 only belongs to C. So our correct answer would be A. That's the law of cosines. We'll focus on that a little bit more soon. And then finally, big number 60. So 60 is something we've never learned before as well. So just see if you can pick up on what's happening here. So suppose the equations, this one here and that one there, are graphed in the same standard xy coordinate plane. So they're graphed on the same graph. So here's my graph. I know that this one looks like a circle, right? That one is a circle. So I know that this, I use the opposite. The center of it is the opposite of this and the opposite of that. So -4 instead of being that is going to be +4. -3 instead of being that is going to be +3. So that's going to be the center. And then remember that this is the radius squared, right? The radius squared. So instead of being 4, the radius is going to be 2, right? Because that is the square root of 4. So I'm going to go over 1, 2, 3, 4, and up 1, 2, 3. Here's the center of my circle. It kind of goes down 1, 2, over 1, 2, up 1, 2, over 1, 2. We have this like circle, looks like that. And then this one that has the division sign here, this one's called an ellipse, right? And basically it's just a big oval, right? And it works in exactly the same way in that we have the center is at the opposite. So the center in this case would be at 4, 10. Don't worry about the division for now, right? The center is at 4, 10. So I'm going to go, here's the same 4, and then I'm going to go up 10. So 4, 5, 6, 7, 8, 9, 10. So the center is like up here somewhere. And then what these are, rather than this telling us how big it is, this is going to tell us how wide it is, how far over on the x it is, and how far over on the y it is, or up and down on the y it is. So this, if I take the square root of 4, I get 2. So on the x-axis, I'm going to go over 1, 2, and the other way, 1, 2. Right, so that's how wide it can be. This is this side. And then I'm going to take the square root of 16, which is 4, and that's my y. So that's how high it can go. So 1, 2, 3, 4. Right, and 1, 2, 3, 4. So that's going to be the top and the bottom. So it goes like this. It goes like that. So interesting that you can graph them like that. The question still says, how many points of intersection do these graphs share? Like, do they ever touch? We can see that this one is far above this one. They don't have any touch. There's some airspace there. So the answer is 0. Great. It's a strange one. If you want to learn more about it, you can learn about equations of ellipses, and then equation of a circle. Cool. You did it!